the worksheet for 16.1 day 2, drawing lines of best fit. Okay, we look at this here. This question we did in class. If we didn't finish in class here, let me go over this question here. Distribute first. You use a calculator, so we've been practicing 2 over 5 times the 10. You should get 4, and then bring down the x. And do the same, get 5, and you get 4x plus 10 here. You subtract the 4x. Subtract the 4x. You get 0 plus 2 equals to 0 plus 10. And you get 2 does not equal to 10. This is no solution. Okay? Now, here, C we did in class. If not, if we got, here it is. Minus 4x, you get 0, and 0 plus negative 21. Here, most of you will probably minus 3x first. Minus 3x. Okay, that's 0 plus 6 equals to 13. Okay, this you add these two because they're both negatives. Negative 7x. Okay, if you see it better as an additive inverse, you can do that too. Notice that, that's still a negative 7x. Okay, now you got a problem like this. Because this is 0, that's why you see people cross this out instead, or put a 0 here, plus 6 is 6. Okay, now then you can get rid of the negative, the 13, so you do negative 13. You get negative 7 equals to negative 7x. Divide by negative 7. Get x equals to a positive 1. This is called one solution, or one answer, because there's only one answer that would work here, negative 1. Okay, we didn't do this. This is it right here. For number 1, and I guess I didn't finish this, but all of you guys can have a different answer here, okay, than this, because you could choose a different points than I did. So as long as your work is right, that you find the rate of change first, okay, and then here you place it here, and you put y1, x1, and then you distribute, you get a 1/3 x. Distribute, use your calculator, 1/3 times 6, you get a 2, y minus 1, then you would add a 1 to both sides, y equal to 1/3 x minus 1. Okay, so let's see, I'll leave this example here to show you how to do that. I think I forgot to write, on your worksheet, if I forgot to number them on yours before I made copies, please number them like this. Okay? Okay, and then you take these points and graph them. 8, 6.5, 8, 6.5 is about right here. Nope. 8, 6.5 is about right there. 12, 11.5, 12, 11.5, about right there. Not quite at 12. 16, 15.4, 16, 15.4, about right there. 20 and 21.5, 20 and 21.5 is about right there. 25 and 24.5. 25 and 24.5. Right there. Okay. And then you draw your line of best fit. Okay. So you would draw differently. Okay. That's fine, but it needs to be close to this. So you can, no, that's not a straight line. Aim it like that. Okay, now, there's two ways you can choose here. I would choose this one here because it's right on there. And that is 18, 18. And then I would choose right here too. Look, that's 21, 21. Okay, or if you choose differently, it's fine too. Let's say you choose this one right here. This one right here is, what's that number? 16 and 15.4? 16 and 15.4. I wouldn't choose that. 15.4 is too hard to work with. You can choose, all these are decimal, so I wouldn't choose the decimal one. It makes it too difficult. Okay, really is. But you can choose any other number. Let's go back to this one, 21 and 21. And then you find the rate of change. I'll show the rate of change here. M equals y2 minus y1 over x2 minus x1. So I would identify this as x1, y1, x2, y2. So we do 21 minus 18 and 21 minus 18, which is 3 over 3, which is equal to 1. Okay, this is important. This number 1 is. You take that and you do y minus y1 equals to m parentheses x minus x1. Okay, y minus y1, which is 18, equals to m. M is the 1, parentheses x minus x1, which is the other 18. Distribute. Didn't change any. X minus 18 equals to y minus 18. Add 18 to both sides. You get y equals to x. There's always a 0 right there. Okay. That's how you do that. Same thing here. You need to graph these. So you need to graph them. Oh, it's really important that when you graph, and which I didn't do here, I didn't label the independent and dependent variable. Independent is the x, that's age in weeks. And independent is weight. Okay, this one I did before I started, so make sure you label the independent, which is the x, and the dependent, which is the y. Okay, 6 pounds, 6 weeks, 15 pounds right here. 12 weeks, 30 pounds, which is right there. 16 and 39, 16, 39 right there. 24, 64, 46, which is about right there, and 30, 51, somewhere there. Okay, you draw the line of best fit, like that. It doesn't have to hit the dots, just need to be in the middle. Okay, so you're going to use this dot, 6 and 15, and another one would be like right here. That is 24 and 50. You do, and some of you at home may use different dots. Now you don't have to have the same dots, and your answer may look slightly different, but your answer needs to be in slope-intercept form like this. The steps in solving is the same thing. Okay, so you do y2 minus y1 first over x2. The change in y over the change in x means the same thing. So it's this one, x1, y1, and this one, x2, y2. Get 24 minus 6, minus, oh, this was 15, sorry. Okay, so 35, we got 35 over, let's see, 18. Divide by 3, no, can't be 3, 6. 35 is just 3 and 7. That's a bad number to use. Oh well. And then you do y2 no, not that one. I'm tired. Really, really tired. Not late, but you use this formula here. This is your rate of change. Y minus y1, m parentheses x minus x1. Y minus y1, which is 15, equals to m, which is 35 over 18. X minus x1 is 6. Okay. And you use a calculator to do this part right here. You'll find the answer. You always distribute first, okay? You'll find the answer. And here's the answer to this if you forget. Basically, it's using point slope right here, but finding slope first. Okay, that's it.